Hi there. In this video, we're going to be going through how to fix failing unit tests, and I'll just be going through my own personal approach for how I do this, how I find unit tests that are failing, and then how I narrow down to the particular backend and the particular function. There are possibly better ways of doing this, so I'm always open to comments or suggestions, but I just thought it might be useful to record my screen and just show you 15 minutes of me trying to fix unit tests, just in case there's anything useful that you might be able to pick up as well. I'm deliberately recording my keystrokes as well, again, in case that's useful. But this is definitely a two-way thing, so I'm also very happy to hear feedback on things I could do to improve my own workflow as well. Yeah, okay, well, without further ado, let's get started. So what I first do is start by running the tests. So I could do test all, but I'd rather start with the functional tests because they're generally a bit simpler to start with. So I'm just going to run that, and then I'll see what's failing first, and I'll get started based on that. So, okay, so very quickly we have from DL pack is failing. It's failing for NumPy and Torch. So let's run that. I'll run it just for NumPy first and then see if that fixes everything. Quite often the problem is the case for all of them. Although in this case, given that it was only for Torch and NumPy, I guess it suggests that probably the problem is framework specific. So I'll probably need to run this twice. So what's the problem? NumPy has no attribute from DL pack. Okay, so I'm just going to come in here. This is how I normally would do it. Again, this is just how I step into the piece of code that's causing a problem at the point at which it causes a problem. Although in this case, it's always going to be a problem, actually. So I don't need this try except. So there's no, okay, so there is one, but it has an underscore. So that's just a naming convention problem. That seems pretty easy. So let's see if that fixes it. Hopefully it does. I'll also just disable it for the statement as well, so we don't get this error. And it passed. Okay, that's quite nice. So I have the process of committing often. Sorry, didn't mean that. Oh my god. So okay. Cool, okay, so that's one bug fixed. We had a problem with Torch as well, I think. I might be misremembering. Let's see. No. Or maybe it was. Maybe we just need to try more examples. So let's just increase this a bit. Let's increase it to 50. Because with hypothesis, we only generate a small number of examples, so a good way to test is to test with lots of examples. Okay, it's failing again. What is the problem? So we can't export tensors that require gradients. This is in the Torch module, so where's the lowest run for us? It's here. Probably we just need to do what Torch is telling us and detach it. I assume that works fine. Again, let's just run this so we can actually step in at the point at which it's failing. Again, like if we just put the breakpoint here, then probably, well, most of the times this passes perhaps, and then we're not actually going to have we're not going to be in the context where there is the failure occurring. So this is something I quite often do. Again, I'm not sure if this is like typical practice, but it's what I've become accustomed to doing. So this is failing, whereas probably if we just do what it says and detach it, it will work, and it does. Okay, so we can then fix this just with I think requires grad is an attribute, I think. Yeah. Oh, I deleted. Yeah, oops. It means to delete everything. Okay. We can also put all of this in one line, to be honest, but there's no need to do that. Okay, let's see if that fixes it. Wicked. Okay. So, oh yeah, let's not do that. Okay. So now let's see if it works for all backends with 50. That would be a good test. We still have 50 in the conf test, so that's okay. Yeah, that's reassuring. That looks good. So now let's go back on the hunt for more failures. And it's quite a slow process. Oh, we're doing 50 for everything. Yeah, we don't need to be quite... I wouldn't normally be quite this thorough when searching for failures, but okay, that's fine. Yeah. Seems like a lot of things are good, but I'm pretty sure, because in the CI there's failures, so I'm sure we're going to find some more failures at the moment. Okay, full like is failing, so let's take a look. I'm actually going to reduce this though, because it's a bit slow, but let's have a look at what full like is failing with. That's an overflow error. I'm going to skip this for now, just because I might make a dedicated video for this. These are likely to be a little bit harder, but let's have a look actually, why not? Let's see if we can work out what's going on here. So the point of problem is here. Let's see if we can come up with something. This is, yeah, I mean, probably this is just a problem. So this was what with torch. So probably we're just generating very large hypothesis examples which are causing overflow, and it's probably not really a bug. Probably we just need to have a larger safety factor in the hypothesis generation or something. Currently we only generate values that go up to 95% of the bounds that the data type can represent. So yeah, it's a very small value. The data type. Oh no, this does seem like a problem. Because I think the fill value and the data type should align. This is not something we should really expect to work, I don't think. So yeah, so we have a data type and a fill value that misalign. So well, let's see if this is a problem in the test itself. Okay, yeah, I mean, this is a problem. The fill value is being generated entirely independently from the data type. And it's also not, yeah, so I think what we should do is just cast it I mean, we should probably just do something. We actually need this to be shared. So ideally, we should pass in. We should have an integer if the data type is an integer data type, and we should have a float if the data type is a float data type. Full like is only going to be producing one array, so that's okay. Do we have a shared variable for this? That is the question. Do we? So when we have the data type, we don't have this with a key. So we're going to need to add that, so there's some codependence here. So this is kind of an example where the hypothesis helper functions are not general enough. And basically, there's not a quick one-liner that can get this, because the fill value should be coupled to the data type. And without having a shared value, using search strategy.shared, then there's no way of doing this. Whereas we actually want this integer or float to, we basically want this to depend on the data type. And I just want to quickly check what full like should be doing in the Array API standard. I wonder what it expects in terms of the fill value in the data type. If the fill value exceeds the precision of the resolved output data type, behavior is unspecified unless implementation defined. If the fill value has a data type int or float, which is not of the same kind as the resolved output array data type, yeah, I mean, so this is up to us how we handle this, and I think we should add a note to this, because I don't think we should be supporting fill values which are not of the same type as the output data type. This is something that we should be explicitly throwing an error for, to be honest. This is one thing that we should have added here, just to give a very helpful error when this happens, rather than just getting these underflow problems. So that's the first thing that I'll do. I'll add in an explicit assertion with a useful failure. But that isn't going to get the test passing, then we need to get the hypothesis test passing. So this is quite a lot to unpack, but this is what fixing unit tests is about. Sometimes they're easy, like dlpack. Sometimes they're a bit more involved, like full like. So that's not a reason to not get stuck in. So let's try and get that fixed. So let's first create a helpful exception and get that pushed. So what we're going to do, we're going to say if is int data type. I can't remember what the data type functions are that we have at our disposal, but I think we can check if it's an int data type. IV functional, IV data type, int whole. Is int data type, okay. And we guess we have the same for float. So okay, so assert that this is the case, and if not, then we should have a helpful error that says the fill value and data type so actually this is there's a lot of things wrong with this function. This also should not be, the data type should not be inferred automatically. It should behave much more like full, where the data type. So yeah, there's this is quite a lot to unpack. The first thing we need to do is go to Ivy creation and find full like, and we need to remove this inferred data type because, as is explained here, let's find the section in the deep dive. This is data types. I don't know where exactly it's explained, but basically this wrapping, we have this kind of relevant scalar. Here we go. So arguments and other functions. So basically this is referring to when we have the inferred data type decorator to a function. And you can go through this in more detail, but basically we have these things called relevant scalars, which are scalar values passed into a function which should be used to correctly infer the data type. So examples of irrelevant scalars are shape or axis or number of dimensions or things like this, which are always necessarily by definition integers, and therefore they're not informative. They're referring to things regarding the shape of the array or something like this, and they're not referring to the data types of the array. So yeah, axis, dimensions, number of dimensions, shape, and all these things are not relevant scalars which can be passed in, or size and things like this. However, fill values are of course relevant, because if we pass a float fill value into a function and we don't explicitly provide the data type, it can be sensibly assumed that we want the target array to be using floats as the data type. Likewise, if we provide a fill value of integers, we expect the generated array to be of integer data type. So the fill value is a relevant scalar, and our infer data type decorator is not clever enough, or we have decided not to try to implement this functionality. It's not clever enough to infer which scalars are relevant and which scalars are irrelevant and handle this all automatically, and therefore our decision is that for functions which include relevant scalars, all of the data type handling should be managed in the function itself and not in the general decorator. Therefore, the infer data type decorator should not be added to full like. It should behave the same as full. And I think if we find full, we'll see that we do not have inferred data type, whereas it was mistakenly added to full like. So the first thing to do is to get rid of that decorator, and for all backends, but I'm just going to focus on Torch for now, we should be adding this back equals none, which is the same as what we do with full. And again, actually, that's true because we're not handling anything at all. This is also technically permitted to be an Ivy data type as well, because we're not going to convert it from an Ivy data type to a Torch data type because we're not using the data type decorator. So this is what it should look like. Okay, so that's the first thing. And then we should basically have similar logic here. So we should infer the data type if it's not provided. This is something we should do early on in this function. Okay, great. What next? Okay, so we've got the data type, we're inferring it manually, that's all fine. But we still need to do this check because the data type might be provided explicitly, and if it is provided explicitly and it contradicts the failure value, this is still a problem, and we still need to raise the error. And in fact, because now we need to do this same logic for full as well, then we might as well put this into a helper. I'll just add it here for now. Assert fill value and data type are compatible. Quite a long name, but that's okay. We're going to pass them in, and we're going to assert this. We're going to write our message in a moment as well. Okay, and then we're going to pass in the data type and the fill value. We're going to do this here, but I'll do that in a moment. There. Fill, oh my god. Okay. Okay, so we have the data type, we assert that it's all good. I don't know what was the problem here, but whatever, that was there before. Okay, so we do this, we do the same in float like, and that's all good. And again, we're going to need to do the same for all other backends, not only Torch. So I'll do that now as well, and then I'll get it pushed. This isn't going to fix the test, bear in mind. This has unpacked a whole deep load of problems, which is exactly what tests should do. But actually, we still haven't fixed this, so we're still going to get these erroneous situations. I mean, we could just, as a quick hack, which we should not push, but we can just manually skip such cases and see if it's passing for Torch. That might not be a bad idea. Yeah, so I've got Ivy. I'll import Ivy quickly here. Okay. So let's see if this passes for Torch. And again, this is not code to be committed. We're going to need to fix this in the generation. If it doesn't pass, so where do we go down the rabbit hole now? Oh, it's a problem right at the beginning. I must have just done something stupid here then. So data type in 16 true. Oh, if it's an integer. Oh, this is the opposite. Yeah, it's incredibly stupid. Yeah. Okay, so I was looking for a problem in the helpers that didn't exist. I might keep all of this in the video anyway, because it's probably more useful to see the tools and the stepping through and stuff, and also maybe good to know that it's very common to spend ages on stupid little things, although it might not make the most entertaining viewing, so I don't know, let's see. Okay, so this is, we're one step further back at the rabbit hole. So what we're doing, so we should be adding this to all backends, and then we should actually be fixing the test so that we don't need to have this check, but we should be able to handle this in the data generation itself. So yeah, let's do the first thing first. Ivy creation has been updated. We have removed the decorator, which we needed to do, but what we now need to do, and I'm just going to get rid of all this so we clean it up a bit. What we do now need to do is add the decorator to every other, sorry, what am I talking about? What we now need to do is add this type hint with a default value of none with this, and we need to then handle this entirely in each of the backends. So what we can do, we've got torch creation, let's get the others open. Let's start with Jax. Full, so we're basically going to have the same here. So it's going to look like this, apart from this is going to be there instead. Get rid of that. We should have the same kind of assertion, so I'm wondering, because this is not torch specific, none of this is torch specific. Also, I need to actually write this message. Yeah. It should still be a private method, but we can actually probably just put it in the Ivy creation, because it's not backend specific, and it was full. Is that below? Oh, I don't know why it's not in order. This should be ordered at some point, but for now let's just put it here. Let's keep it private. We're going to get a few warnings about this, which we can just ignore. Like here, it's going to go like this. What else is wrong with it? Oh, the private. And this is actually pretty much copy and pasteable, I think. I mean, actually, we've got lots of this here. We don't need all of this. We kind of, we're handling that now. So we could just put data type there. Okay, I think that looks good. So that's Jax, it's torch. We now need to do it for MXNet. Actually, we're not testing for right now, so I'm just going to leave that out for now. Also conscious of the video length a bit. And again, this might seem like a bit of code duplication. That's true. This is exactly why we have the handle data type decorator, so that we don't need to write lines of code like this all over the code base. But for the time being, when there is this unique setup where there is a scalar value that is relevant for the data type, the easy solution is for that small minority of functions just to do it in each of the backends. This is the best solution we've come up with so far. So we're now into NumPy creation. And then TensorFlow. Again, we've got all this stuff we don't need. In fact, oh, what did I do? What have I done? There might be many instances actually where we're passing data type into all of this stuff, which is no longer necessary because now data type for most functions is actually required. It is actually required to be fully specified by the time it arrives, such as here. Yeah, so all of this is actually irrelevant now. I mean, I'll do it for this one quickly, but I mean, this is something. Actually, it will make the commit a bit untidy, but basically, yeah, we can remove all of this kind of logic. It's completely necessary. I'm actually going to make a quick note about that. I forgot where we were. Full like is where we were, I believe. Oh no, full. Full is where we were, and we now have this all looking good. Again, this device stuff is not necessary. This native and default device because it's now specified, and it's handled by the decorator. But this is something for another commit and for another task. We're just trying to get test passing right now. Let's stay focused. So let's see if this passes for everything. Let's see. I'd be surprised, but you never know. There's normally a little mistake here or there. Yes, there is. And it's for torch. And what's going on? Oh, okay. That's a nice, easy one to fix. They're the kind of errors I like. Let's try again. I think we have 50 data examples being generated still, so if it does pass, it suggests it's working. What now? Okay. It's because it's private. I don't know what the best thing to do is here. We could just copy it into all backends, but that seems a bit ugly. For now, no. Yeah, let's just do that for now. It's always easier to refactor things than it is to have a bad refactoring, I find. So let's just have it duplicated and we can probably clean this up later. We don't want to add this as a public method and have it on the doc strings and everything. That would not be great. So we can just clean this up like this. A bit of duplication isn't a disaster, so that's okay. Yeah, and it is just generally, I find it's better to accept a bit of duplication rather than refactor things in a way that isn't ideal. It's always easy to refactor things later if you need to. Full like is wrong for Jax as well. No, full, yeah. We should have added this here in the first place. Also don't need this anymore. I might have accidentally updated the wrong thing, but both of them need the update anyway. They both basically need the same treatment. So let's see where we are. So this was just some debug code changes we made. I mean, why not? Let's do it for full and full like. I think I might have made changes to functions that were needed. The one we actually are caring about right now, sorry, is full like. That was the test that failed. That's what we're testing, so let's just focus on that first. So torch, jax, numpy. Let's put it above full though, because it is relevant for both. Yeah, I was changing the wrong thing actually. Okay, numpy, TensorFlow. Oh, I should have written this before I copied it everywhere. I was changing full everywhere. I was testing full like all over the place. Okay. Okay, I think that's good. Yeah, let's see. Okay, nice. So I'm just going to change the, I'm not going to update the test yet because what we've added in the test is actually not correct. So let's just add Ivy functional. Let's do it step by step. Does that all look good? Yeah, we want to assert. We want to make sure the data type is none. We need to handle the data type. Yeah, that looks good. Yeah. Yeah. Yep. 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 Okay, that's good. So now let's just say fixes to full and full like for all backends where the data type is handled entirely by the backend in both cases. So yeah, I mean that's fine. Fixes to full and full like for all backends where the data type is handled entirely by the backend in both backend for both functions. I actually don't think there was a single thing we didn't add in those, so I don't need to do the P again. Okay, happy with that? Okay. Oh, I didn't mean that. That's status. What is the difference now? Just the test. Oh yeah, some debug code as well, which we shouldn't add. That's good. And also this is wrong. We're getting there. This is a much longer video than I thought, but I'm really determined to get to the bottom of this before we finish. So let's now get the hypothesis stuff working correctly. Okay, let's do it. So what we need to do is we need to go to the test, which is test fill like was what we were testing. Let's get rid of all this debug code for now. Okay, we need to get rid of this, and we need to be doing it in here instead, and then everything should be working beautifully. What we want to make sure is that the fill value is connected and is coupled to the data type generated here. At the moment, these are generated at random independently, and therefore we get conflicting incompatible combinations. So what we should be doing is having, we should, for example, be having a shared value which is called like isInt, I suppose. And based on this, so I actually need to work out how we do conditionals, but what we should basically be having, so let's make this shared, because the fill value can just be shared, I think. So let me just have a bit of a think. I mean, let's just make a quick helper. Just for now. And this is probably also required for full. Yeah, I mean, there's a hack here, which I'm not going to fix now because I'm just fixing failing tests. This is what I'm doing. I'm not kind of correcting incorrectly implemented tests that are passing, but if I was, then this would also be changed because it's the same problem. But let's create a helper which is called fill value, and let's just like refactor to here quickly, and let's just bring things up here first. Call it, I think that's right. Let's check. I want to probably return. I need to return something. That is not correct. Yeah, okay, good. Okay, so we're here now. So we should have a shared value, which is something like int or float. So I actually think I'm actually going to do this in another video because I'm thinking this video is getting too long, but we can carry this on in the next video. Yeah, just so we can cut this here, so it's not like it, I don't know how long it's been, but it's been a while. I can even probably look here. I don't know, I don't even see the time. It's been nearly an hour, so let's cut the video here and I'll do this in the next video. Hopefully that was useful. It ended up being a very deep dive into one particular function, full-like, and we ended up diving into a whole load of different topics. One of them is the data type decorator. We ended up diving into how we can maybe provide frameworks, back-end specific helper functions to help us deal with certain things. So it was quite a deep dive, and I kept getting stuck. I was then trying to work out what's going on, and more than showing how to fix a problem and what and kind of this is not a tutorial on the function fill value. Sorry, this is not a tutorial on the function full like. This is a tutorial on using the IDE to try to solve arbitrary problems, and hopefully shines a bit of light on Ivy, the framework, shines a bit of light on how to make use of your IDE, hopefully the key stroke tracking and the kind of flipping around files might provide some value. Might also show you that you're not alone if you get stuck on really easy things for a long time. It took me an hour to fix this, so yeah, I don't know. If it takes you a long time, I think it takes most developers, or depends how good you are. There's many developers much better than I am, but it's very normal to get stuck on things for a while, so a bit of proof of that. Yeah, and that's everything, I think. So thank you very much for watching. Hopefully this was a bit useful, and I will see you in the next video. Thanks a lot. Bye for now.